The first formula is Q is equal to mc delta T. Now Q is also equal to capital C prime delta T. Another is power into time is equal to Q. So both the formulae can be replaced by this. The fourth is heat lost by hot body is equal to heat gained by cold body. So based on these formulas, we will be solving the questions. Okay. So the first question, it says 10 grams, 1 minute. Yeah. By imparting heat to the body, its temperature rises by 15 degrees Celsius. What is the corresponding Kelvin scale? Now, we have done this in the previous class, that a degree rise is equal to a Kelvin rise.
That will be 50 Kelvin.
So, yeah, this is 15 degrees Celsius. So, therefore, in Kelvin scale as well, this will be 15 Kelvin. In the second question, it has the following information. They have given the mass to be 150 grams, and they have given the specific heat capacity is 410 joule per kg per Kelvin. And they are asking us to calculate the heat capacity. So we know that heat capacity is mass into specific heat capacity, but you have to note down that mass is in gram and this is per kg. So what we do is we write the mass in kilogram, and this is 410. So the answer that we will get, we will be having this 0, 0. So this is 15 into 41 divided by 10. That will be 61.5 joule per Kelvin. Okay, so that's the answer. And the second part of the question is, how much heat energy will be required to increase the temperature of the vessel? So over here, the rise in temperature is 35 minus 25. So that is 10 degrees Celsius. And heat required will be C prime delta T. So that is 61.5 multiplied by 10. That will be 615 joules.
So,
yes.
Do we have to remember the derivation of these formulas?
It will be good if you remember. That will be help you. Will be easier for you to solve questions because you'll understand what's happening. So here the mass is 2 kilograms, and the heat capacity is not specific heat capacity. Heat capacity is 966 joule per Kelvin. Now they are asking the amount of heat required if it has to raise the temperature by 15 degrees Celsius. Okay, and they are also asking you to calculate the specific heat capacity. So Q is equal to C prime into delta T. So 966 into 15. So that value will be 14490 joule. Yes, Miloy.
So what is PT equals to Q?
that is power into time, that is energy.
Answer Q is the heat energy.
Yeah.
Okay.
So here you have 966. This is 2 into C, small c. So 966 upon 2, 483. So this will be 483 joule per kg per Kelvin. That will be the heat capacity. Okay. Calculate the amount of heat energy required to raise the temperature of 100 grams of copper. So mass is 100 grams. And the rise in temperature is 70 minus 20. That is 50 degrees Celsius. Specific heat capacity is 390 joule per kg per Kelvin. So they are asking us to find the energy required, which is mc delta T. Now this is 100 grams and this is joule per kg. So that has to be expressed in kilograms. So this is 390 and 50. 1, 2, 3, 1, 2, 3. So this answer will be 39 into 50. That will be 1950 joules. Okay, so now that you're following these questions, there will be other questions where a body will be losing heat, another body will be gaining heat. Those kind of questions. Right now, we start with question 6. It says that you have to find the time taken for a heater. So the heater has power, which is 500 watt, and it is raising the temperature of 50 kg. Okay, 50 kg material of specific heat capacity, that is 960 joule per kg per Kelvin. Okay, and the rise in temperature is 38 minus 18. That will be 20 degrees Celsius. Okay, so we have to find the time. So like I told you, power into time will be the amount of heat. So this is 500 into T. This will be 50. This will be 960. And that will be 20. So 50 into 960 into 20 upon 500. This will be 10. So 960 into 2, these many seconds. If you leave your answer in second, that's okay. If you have to convert this into minutes, you will have to divide by 60. So 2 ones are, 2 threes are. It will be 32 minutes. So that's the time required for the temperature to rise from 18 to 38 degrees Celsius. Okay, after this, we will do question number 7. Question 7. There is an electric heater, so the power is given to be 600 watt and mass is given to be 4 kilograms, and the temperature rise is from 15 to 10, so that is 5 degrees Celsius, and time is 100 seconds. So they want to calculate the heat capacity and also the specific heat capacity. Okay, so we know power into time is mc delta T. So this is 600 into 100. This is 4 into small c into 5. So we get this 600 and 5 fours are 20. So that will be 5. So 300 joule per kg per Kelvin. So that will be the specific heat capacity, and the heat capacity will be M into C. So that will be 4 into 3000. That will be 12,000 joule per Kelvin. Okay, you can write this as 3 into 10 to the power 3. And here this is 1.2 into 10 to the power 4. You can mention that. Okay, so here we have 50 gram of certain metal. Now I'm going to write it this way. There is metal, there is water, there is a mass for them, initial temperature, final temperature. Okay, so we have the metal, which is 50 grams, and then it is at 150 degrees Celsius. It is immersed in 100 grams of water, which is at 11 degrees Celsius. The final temperature is obtained to be 20 degrees Celsius. So therefore, here we get 130, and here we get 9. Okay, degrees Celsius, degrees Celsius. This has to be calculated, and this is given to be 4.2 joule per gram per Kelvin. Right. Okay, so what we have to understand is assuming the specific heat capacity of water. Okay, now by the principle of mixtures, okay, if no heat is lost to the surrounding, then the heat lost by hot body is equal to heat gained by cold body. Okay, now remember earlier when we had done numericals of force chapter, where we had written that if the scale is balanced, the total sum of clockwise moment is equal to the sum of anti-clockwise moment. So similarly, this statement is important over here. So now we write M1 C1 delta T1. Yes, Miloy.
So I didn't understand the statement.
The statement is that, as you can see, the metal is at 150 degree and water is at 11 degree. It has lost heat and come to 20 degree, whereas water has gained heat and the temperature of water has come to 20 degrees. So that means all the heat that is lost by the metal is gained by water. So that is what we are writing. There is no heat lost to the surrounding. So that means all the heat that the metal has lost is gained by water.
So, but that is not possible, right? So
No,
because metal was at 150 degrees.
that is the assumption that we are writing, no? The premise that we are writing over here and then writing this. Are you following? We are writing this assuming this part. Do you follow that? Okay, and in the calorimetry experiment example, I told you there are measures are taken to prevent the loss of heat, like there is the lid on top and all that. Fine.
Yes, sir, but I didn't understand. So 150 minus 20 does not equal to 11 plus 20.
That's the change in temperature, and here we are talking about heat. You get it? Okay, heat loss is not temperature loss. Okay, heat is this much, not just temperature. Do you follow that?
Okay, sir.
So 50 grams of metal And let's take this as x, and this is 130, and this is 100 into 4.2 into 9. So x will be 100 into 4.2 into 9, and this is 50 into 130. So this is 2za. Okay, we can do this 2 into 42 into 9, and this will be 130, and this is another 10. 13 tens are 13, this is 3s are right. Yeah, and so we have 3 to the 6, 6 into 9. Yes.
The 13 threes are 39, not 42.
No, I'm talking about yeah, this is a mistake, right? This is not 3za. So what we will have to do is we'll have to take this 42 into 2 into 9. So that will be 756, and this will be 13 into 100. Okay, so if we divide 756 by 13, so 13 5 will be 65, 106. So 13 into 8 will be 104. 1s are 7. That will be again 5. Okay, so we can write this as 58.15. So that will be 0.582. So the value is 0.582 joule per gram per Kelvin. Okay, remember you have to write correct up to 2 decimal place. Right. Now in this question, we are going to write about hot water.
So can you just show that statement for 1 second?
Cold water. Yeah, I will be writing down over here. So mass will be 200 grams of hot water, and the initial temperature is 80 degrees Celsius. And this is 300 grams of cold water, which is at 10 degrees Celsius. And they are asking us to calculate the final temperature. So we can take that final temperature as T. Okay, since it is water, so the specific heat capacity is same for both. Here we write if no heat is lost to the surrounding, then the heat lost by hot body is equal to the heat gained by cold body. Okay, so again M1 C1 delta T, M2 C2 delta T. Here we can write delta T as 80 minus T, and here we write T minus 10. Okay, so here we get 200 into C into 80 minus T, and 300 into T. So here we cancel this C and C because that is both for water. Here zeros. So this will be 160 minus 2T, and this is 3T minus 30. So here what you asked earlier is of significance. So one has to understand whether to take T minus 80 or 80 minus T.
Plus
So
over
this
here, the
will be
cold
30.
water is gaining heat.
Yeah.
So
this
that is
is
why
what
the temperature will be more.
Yeah.
Okay, sir.
So this is 190 by 5. 5 3s are 15, 36 degrees Celsius. Now you have to write the final temperature. This is 4, so 38 degrees Celsius. Yeah. So final temperature of the mixture is 38 degrees Celsius. Fine. So after this, we'll do question number 12. The temperature of 600 grams of cold water, 600 grams of cold water rises by 15. Now, this is the very important statement that delta T is given, rises by 15 when 300 grams of hot water, okay, at 50 degrees Celsius. So this, which is at 50 degrees Celsius, is added. What is the initial temperature of cold water? So they are asking, what is this? So let us take the final temperature to be T. So here we have 50 minus T. Okay. Again, we write down the same statement and we write 300 into C into 50 minus T is 600 C into 15. C get cancelled here. 3 ones are, 3 twos are. So 50 minus T is 30. So 50 minus 30 is T. So T is 20 degrees Celsius. But remember, this is the final temperature. We want the initial temperature. So we have 20 minus 15 is equal to T1 and T1 is 5 degrees Celsius. Okay, so this is a cold water. The cold water temperature rises by 15 to become 20. That means it was at 5 degrees Celsius. Okay, it was at 5 degrees Celsius, then only it will rise by 15 to become 20 degrees Celsius. The question says 600 grams of cold water, the temperature rises by 15 degrees Celsius. So that's the reason why I wrote 15 over here. Okay, because delta T means change in temperature, whether rise or fall. Rise for cold water, fall for hot water. The second
Yes.
part of the question says that when 300 grams of hot water, which is at 50 degrees Celsius, is added to it. So the final temperature is not given. They could have asked us that as well. So I took the final temperature as T. So delta T is 50 minus T. Okay. And over here, delta T will be T minus T1, that is 15. Then the statement and then M1 C1 T1 is equal to M2 C2 delta T2. On solving, I got T value as 20 degrees Celsius. That means the final temperature is 20. It is given that the cold water's temperature rises by 15. It rises by 15 to become 20. That means the initial temperature has to be 5 degrees Celsius, and that is our answer.
Sir, why did you equate T and T?
Which T and T?
So the final temperature of both is same.
Yes, of course, it will be same always. That's the heat that is lost by the hot body,
Yes, sir.
gained by
Yes.
the cold body till the temperature becomes equal.
Yes, sir.
Okay, we start the 13th question. Now over here, mass of water is given to be 1 kilogram, and the change in temperature from 25 degrees Celsius it is taken to boiling point, that is 75 degrees Celsius is the change in temperature. Then specific heat capacity is 4.2 joule per gram per Kelvin. Power of the kettle is 1.25 kilowatt. They are asking us to calculate the time. So we know power into time is mc delta t. So that means 1250 into t. Now this is 1 kg. I'll write it as 1000 grams because this is 4.2 and this is 75. So therefore we get 1000 multiplied by 4.2 and 75 and 1250. So 25 5s are 25 4s. So you get 4 into 42 into 75 and this will be 50. Again this is 2 and this is 3. Now these many seconds, okay, you can write your answer in that. If you wish to write it in minutes, so you have an option that will be 60. 6 7s are 6 10s are. So that will be 7 2s are 14. 14 into 3, that will be 42. So that will be 4.2 minutes, or you can write it as 4 minutes and 0.2 minutes will be 0.2 into 60 and that will be 12 seconds. So 4 minutes and 12 seconds. So either write your answer this way or this will be 42 into 6, that will be 252 seconds. Okay.